Hey there, everybody. Welcome back. Guess what? It's time for dividing rational expressions. This is 5.2b. We did multiplying in the last video. We're going to do dividing. I want to remind you how it worked with fractions. If I had 2 over 5 divided by, I don't know, 6 over 15, what we did is we flipped this and made it multiplication. We factored. This is 5 times 3 and the 5's cancel. This is 2 times 3 and the 2's cancel. The 3's cancel. And this would just equal 1. So flip and make multiply. Turn to multiply. Part A, part B, factor and cancel like expressions. And just clean up, simplify. This isn't any different with rational expressions. Same process if there's variables. Isn't that wonderful? Oh my gosh, that just made me think of Dungeon Carl. Carl, if you haven't listened to it or read the book, the audiobook is much better. The host of the Dungeon Crawler world, she talks like that. Isn't it wonderful? And she always says it like in that high-pitched tone when it's something people don't like. And I know you guys are not going to like this because it's a lot of work. But it is what it is. We're going to factor and cancel. So let's look at some examples. Let's do 12x squared y to the 5th power over x plus 5. And we're going to divide that by 3x cubed y over x squared minus 25. All right, first step. Flip the second or anything being divided and turn to multiplication. I recommend doing that first before you factor. Because if you factor first, sometimes factoring takes a while and you're just gonna forget you haven't flipped yet. So flip first. Always flip first. Factor what you can. 12 is 3 times 4, which is 3 times 2 times 2. I will leave the x squared alone. The y to the 5th power. The bottom doesn't factor. The second one, the numerator x squared minus 25 turns to x minus 5 and x plus 5. And the denominator also doesn't factor. It's already in factor form. All right, so cancel thing that appears on top and bottom. Bottom is shorter here, so I'm going to go through the bottom. I have x plus 5 here. It cancels with that x plus 5. I have a 3 here. It cancels with that 3 there. X cubed is x squared times x. So I can cancel the x squareds here. And y to the 5th power is y to the 4th times y. So I can cancel the y's there. What I'm left with on top, I've got 2 times 2 times y to the 4th times x minus 5. On bottom, I just have an x. So this cleans up to 4y to the 4th, x minus 5 over x. Okay. Let's take a look at the next one. Let's do 4x squared minus 25 as the first numerator. And the denominator is 3x squared minus 16x plus 5. Divide that by 10x plus 25. No denominator. All right, first step, flip. It doesn't, that should say x squared right there. 3x squared minus 16x plus 5 here, that stays the same. We change this to multiply. If I want to flip this, I got to put that over 1 real quick so that when I flip it, I can't, so that I have something to flip. Okay. Now we can factor. If it helps, I'll call this A, B, and C, and I'll do them separately, then we'll put them all together. So 4x squared minus 25, that is 2x squared minus 5 squared. This is a difference of squares. So 2x minus 5, 2x plus 5. I'm gonna put a little red box around it so that I remember where it is. That's A. B. 3x squared minus 16x plus 5. 3 times 5 is 15, and it needs to add to negative 17. To add to a negative number, one of the numbers has to be negative. And for it to multiply to a positive number, they both have to be negative. It looks like negative 1 and negative 15. So we're going to have to do this by grouping. Group. This is x times 3x minus 1. I will pull out a negative here, and it looks like they have a 5 in common. 3x minus 1. We get 3x minus 1 times x minus 5. That's B. C. (10x plus 25) is pretty easy. It's only divisible by 5, and we get a 2x plus 5. So that's C. I'm now going to put it all together. I had for A, I had 2x minus 5 times 2x plus 5. For B, which is the denominator, I had 3x minus 1 times x minus 5. And I can multiply this all together now. This was 5 times 2x plus 5. And I don't need the 1 here since I multiplied. And we'll see what cancels. So does a 2x minus 5 exist on bottom? It does not. 2x plus 5 does, though. Oh, something else I didn't tell you about dividing rational expressions. We'll cover it here. I didn't cover the domain part. There's a special bonus to the domain. We're going to see that the final version of this is 2x minus 5 on top. And then I've got 5 times x minus 5 times 3x minus 1 on bottom. The domain violations come from both pre-flip and post-flip, which didn't do a lot here. So domain violations are denominator of first fraction or where do they come from? And then both numerator and denominator of the second fraction. And we'll do it a little bit more on the next one, which is a little bit more going on. So this one didn't actually have it. So again, it's going to be these ones right here. 3x minus 1 cannot equal 0. X minus 5 cannot equal 0. And 2x plus 5 cannot equal 0. If this had anything in the denominator right here, that would count as well. Let's take a look at the next one. Where are we? 4x squared plus 32x plus 64 over x squared minus 7x divided by x squared minus 6x minus 56 all over x squared minus 49. Okay, so x squared minus 7x cannot equal 0. It's the denominator here. X squared minus 49 cannot equal 0. It's the denominator here. Next, we're going to flip and change to multiply. And now I can see this as a bonus one. 2x squared minus 6x minus 56 cannot equal 0 also. So those will be domain violations. And we'll look at them in a second. We'll see the factored forms here, and we'll get them from there. So I'll call this A again. This will be B again. Let's go with C here and D here. So this is B, C, and D. When we get the factored forms of those, we'll make notes of their violations there. All right, I'm going to do it one step at a time. A, 4x squared plus 32x plus 64. I can factor out a 4, and it leaves x squared plus 8x plus 16. And when you factor that, this is going to be 4 times x plus 4 times x plus 4. So that's A. We take a look at B. X squared minus 7x, we can only factor out an x. That will be B. C, x squared minus 49 is the difference of squares. That's C. And D is going to have a little bit more work. We need to factor out a 2. I get x squared minus 3x minus 28. Oh, that's a little bit easier to see. This should be x minus 7, x plus 4. Go through and do what you need to do to confirm those. But you already know how to factor. We did an entire chapter on it. We're not going to recover it here. All right, so no, these are my domain violations. We'll take a look at them at the end. Let's put our factored stuff back together again. So A was the upper left fraction. B was the lower right fraction. C was the numerator on the right. And D was the denominator on the right. And it looks like maybe I should factor this 4 into a 2 times 2 because I have a 2 in the denominator. All right. It doesn't matter which one I go through. I'll go through the bottom. I do not have an X on top that is by itself. I do have X minus 7 that cancels in a pair. I do not have another X minus 7, but I have a 2. And I have an X plus 4. This leaves behind a 2 right there, X plus 4, X plus 7 on the top, and the bottom is X times X minus 7. Now, I'm perfectly happy with it being left that way. Other teachers might, or your employer, if you have to do this at work, might want you to multiply out that top. That's 11x plus 28. The bottom is x squared minus 7x. So finish multiplying it out. 2x squared plus 22x plus 56 over x squared minus 7x. These are identical. I like this one better. Let's go back and look at our domain violations. I've got x plus 4 twice, but I only need to write it once because you can't just violate the same value. You can't do it twice. So x plus 4 cannot equal 0. From B, I have x cannot equal 0 and x minus 7 cannot equal 0. And from C, oh shit, A was not a domain violation, just B, C, and D were. B, C was x minus 7, so x minus 7 cannot equal 0. X plus 7 cannot equal 0. D had x minus 7 and x plus 4. Looks like x minus 7 was repeated a few times. If I condense this all down, x cannot equal 0. X minus 7 cannot equal 0. X plus 7 cannot equal 0. And x plus 4 cannot equal 0. Which gives us 0, 7, -7, and -4 as violators. Okay. Wasn't that fun? Aren't we having a good time? Let's kick it up a notch. Go big or go home. And you don't have the option of going home because you're probably at home already. Y plus 3 is the numerator, the first one, over y plus 6, divided by y squared plus 5y plus 4 in the numerator, y squared plus 3y plus 2 in the denominator. Oh, third fraction, another division. Y squared plus 5y plus 6 over y squared plus, that looks like a 10. 10y plus 24. So having two divisions, remember we go left to right. So we're like dividing this, we'll have an answer. Then we would divide this. It ends up turning out that both of those just flip. So I'm flipping the second and third fraction. And we'll label them A, B, C. Now, this is A, this is B, but they're already factored. C, D, E, and F. Our violations will come from B, C, D, E, and F because they were all in the denominator at some point. All right, so we now we'll start factoring. I'll do C, D, E, and F below. A and B are already factored. So if we do C, y squared plus 3y plus 2 is y plus 2, y plus 1. D, y squared plus 5y plus 4 is y plus 4, y plus 1. When they're all positive, the way I'm doing this so quick, when they're all positive and B is 1 larger than C and A is 1, it's got to be 1 in B or 1 in C. That way they add together to make B. E, y squared plus 10y plus 24 factors into y plus 6, y plus 4. And F, y squared plus 5y plus 6 is y plus 3 and y plus 2. So let's make a list of things that make a violation here. I'll do it on the left real quick. B says y plus 6 cannot equal 0. C adds y plus 2, y plus 1. D has y plus 4, and it already has y plus 1, so I'm not going to list it again. Maybe I'll just list over here where they came from. This is D and E. Nope, that's just D. This is D and E. There we go. And F has y plus 3 and y plus 2, which we had above. So those are our domain violations. If we solve that, we get y cannot equal -6, -2, -1, -4, and -3, which will make a fun interval notation. All right, let's put our fractions together and cancel. I've got y plus 3 over y plus 6. And C was y plus 2, y plus 1. So that's A, B, C. D is y plus 4, y plus 1. And then we got E and F. E was y plus 6, y plus 4. And F was y plus 3, y plus 2. And that was E, and that was F. All right. Now we can cancel. I'll go across the top. Y plus 3 shows up in F. We replace them with a 1. Y plus 2 shows up in F. It's replaced with a 1. Y plus 1 shows up in D. Those get replaced with 1s. Y plus 6 shows up in B. And y plus 4. Look at that. I don't have anything left. That all simplified to 1. How about them apples? All right, that's it for this video. We've got 6 more sections in chapter 5. Hang in there, folks. We're over halfway. Peace.